Okay, welcome to Kimat.com. We are going to make exercises on Hess laws. To solve this type of problems, we need to organize the given chemical reaction where the total effect yields the reaction needed. What that means is that we are going to take this set of reactions here and somehow we have to make this reaction. So we need to organize this set of three reactions to given that one. So we're going to start with the products of this reaction. So we have 4 atoms of nitrogen oxide. So in my first equation here, we have 2 atoms of nitrogen oxide. I will need 4, and it's in the right place, in the product side. So we need just to multiply this reaction by 2. Then we'll see what happens with water. We got 6 molecules of water, and water here at my third reaction, we got only 2 molecules of water and is in the product side. So the reaction is okay, but the atoms not. So we have to multiply this one by 3. Then let's see what happened in my reactant side. We got ammonium, but in my second equation we have ammonium in my product side, and it should be in the reactant side. So we have to flip this equation. Flip it and multiply by 4. So that one we are going to multiply by 4. Actually by 2, because we got 2 here. So let's do it. My first equation will be 2N2 plus 2 oxygens equals 4NO. These 4 molecules of nitrogen oxide matches this one. Then my second reaction, we're gonna flip it, but we're going to multiply by 2. So it's going to be 4 NH3 2 Na2 plus 6 H2. Okay, and then we have my third equations. We have 3 times 2 is 6 H2 plus 3 O2 produce 6 H2O. So then we are going to cancel out whatever is equals in both sizes. So we have 2 and 2 and 2 and 2. We got 6 hydrogens, and then we're going to, let's see if we make the equations. We got like addition. We got 4 NH3. We got 2 oxygens plus 3 oxygens. This give you 5 oxygens and produce 4 NO plus 6 H2O. Okay, so this equation match my original equations. So one thing here in my second reaction, because we flip it, my delta H here will be positive. Okay? Alright, let's do the second example. So we are going to organize and let's see what happened here. So we have in my reactant side we got C2H5OH, and right here we have in my first equation we have C2H5OH and my reactant side. It should be on my product side. So we're gonna flip this equation. And we don't need to multiply for nothing because we have only one molecule of that compound. Alright, let's see what else we got. And my reactant side we have oxygen, and the oxygens here are in the reactant side, carbon 2, and hydrogen 2. So we usually have to worry about the how many atoms out of those. So we have 2 atoms of hydrogen and we have only 2 here, so we have to multiply this one by 2. And for carbon we got 2 carbons and we have only 1 here, so have multiply this one by 2 also, and then we have to add all the equation. So we said that this one we have to flip it, so we have 2 CO2 plus 2 H2O produce C2H5OH, and this value has to be changed, 875 kilojoules. And then the second equation we got 2 carbons plus 2 oxygens produce 2 CO2, and my third equation will be 2 hydrogens plus 1 oxygen produce 2 waters, and then we are going to cancel out whatever it is in both sizes. We got 2 CO2s and 2 CO2s. We got water, 2 molecules of water and 2 molecules of water, and then we had to add. So we had 2 carbons plus 2 hydrogens, and on oxygens we have this one will be 1. Okay, so we have here, and this is sorry, this is plus 2O2, right? So we have this one and this one cancel out oxygens, we have only 1 oxygen and produce C2H5OH, and this is the same equation that we need from that one. Okay, thank you. Watch schema.com. We have resources in chemistry, physics, and mathematics.